Yeah. This is your fourth unit syllabus. So in our textbook, Spark advantages over Hadoop. So what is meant by lazy evaluation? What is meant by in-memory processing? And what is the meaning of a direct acyclic graph? Spark context, Spark session, resilient distributed data, transformations, narrow and wide actions. What are the data frames? RDD2 data frames, Catalyst Optimizer, data frame transformations, working with the dates and timestamps, working with nulls in data, working with complex types, working with the JSON, grouping, window functions, joins, data sources, broadcast variables, accumulators, deploying Spark on premises, cluster deployments, cluster managers like standalone mode, Spark on Yarn, Spark logs, the Spark UI history server, debugging and Spark first aid. Okay, so first of all, what is the meaning of Spark advantages over Hadoop? If you see, Hadoop is a framework which integrates a number of tools like Hive, HBase, Zookeeper, Cassandra, Oozie, Pig. These are the tools are integrated with the Hadoop. The major components of Hadoop is HDFS and MapReduce. So, like Hadoop, Spark splits up large tasks across different nodes. Yes. So, with the help of Hadoop distributed file system, first takes as input to the system. The file will be divided into number of chunks. Each chunk will take each node. However, it tends to perform faster than Hadoop and it uses random access memory, that is in-memory computation, to catch and process data instead of a file system. Yes, there is no file system concept in Spark because the entire file will be stored in the RAM, and whenever we are loading that file, first time it takes from the hard disk and remaining times it loads from the in-memory computation. That means random access memory. This enables Spark to handle use cases that Hadoop cannot. That's why Spark is better than 100 times better than Hadoop. So Hadoop runs on system as batch processing, and whereas Spark runs on streaming processing. So that is the, see, I'm going to explain the differences between Hadoop and Spark. Before going to that one, uh, what are the differences between relational databases versus big data? That means Spark. So then you come to know what are the major differences between Spark versus Hadoop. See, in relational databases are SQL, MySQL, Teradata, DB2, MS Access. So where we are using schema, where we are using relation, table, procedure, syntax. For creating a tables, table is a combination of rows and columns. Columns are also called as attributes. Columns are dimensions playing vital role in order to process any data set. So it deals with gigabytes to terabytes, whereas in Spark it deals with petabytes to zettabytes. So in relational database tools, it is a centralized, whereas in big data Spark it is distributed, because we are using HDFS concept, Hadoop distributed file system. The file is taking as input to the with the help of HDFS. We are storing over there and dividing file into number of subparts. Each subfile will take into the each subnode, like client server technology, master and slave node architecture. All data nodes will be at the client side, and master node sharing information to the data nodes. After completion of the data node's task, immediately it acknowledges to the master node. How do you know one data node is not working? Based on heartbeat, we are finding which subnode is not working, which subnode is working. So that is called a fault tolerance concept. In relational databases, it deals with the structured data, whereas in Spark, it deals with the semi-structured and unstructured. Structured data is created with the help of relational database tools, where we are using schema, where we are using relation, where we are using procedure and syntax with help of relational databases like SQL, MySQL, Teradata, DB2, MS Access, etc. It deals with the semi-structured and unstructured data in Spark. So unstructured data is nothing but there is no schema, there is no relation, there is no syntax, there is no procedure, but we are creating the databases with help of non-relational databases such as Mongo database, Hive, HBase, Scoop, Cassandra, various database, non-relational database tools we are using in order to handle the semi-structured and unstructured databases. Next, fourth difference is it is having stable data model. It is having unstable data model. See, data model is nothing but simplified version of the reality. Whatever you are doing updation in the model, it will be sequentially following in data model. Whereas in Spark, it is having unstable data model because we are handling with the unstructured data. In the fifth point, it deals with the known complex interrelationships by using relational database tools. Whereas in Spark, it deals with the flat schemas and few interrelationships. Then in relational databases, tools are SQL, MySQL, DB2, Teradata, MS Access, etc. Whereas in Spark, tools like Hadoop, Spark, or Mahout, various tools we can integrate easily in Spark. So the seventh point is, so in relational databases, access is interactive and batch processing. A group of tasks working with old data, legacy data, historical data with help of relational database tools. Whereas in big data Spark, access is batch processing and as well as streaming. The eighth point is updates are read and write many times because every time it loads with the hard disk. So in big data Spark, updates are write once and read many times. That means every time it loads with the in-memory computation with help of RAM, random access memory. The ninth point is integrity is high because We are using various relational database tools for structured data. That is the reason. Whereas in big data Spark, integrity is very low because of we are handling with the live and streaming data. Whereas the relational database tools, scaling is non-linear, and in big data Spark, the scaling is linear. These are the 10 wonderful points about relational databases versus big data Spark. Now see here, Hadoop versus Spark. You can expect this question in final exam. Differentiate, write differences between Hadoop and Spark. You need to write parameters in left side. What are the parameters we are considering between Hadoop and Spark? Hadoop and Spark are two big data process tools. In order to process big data tools, traditional systems are unable to process. That's why we are going to process with the help of Hadoop and Spark. So if you take the first parameter, performance. So process data on disk, process data in memory. In Hadoop, whatever the performance we are performing, suppose you are taking 1 zettabyte file in a server. So that time the process data on disk, every time it loads data from the hard disk, that is called disk, read only memory. In Spark, performance process data in memory because write once and read many times. So that is in a random access memory. So Spark also a framework integrates with the n number of tools like uh, mlib and pig or Python, Zookeeper, Woozy, Cassandra, any tools we can integrate very easily. So ease of use, next parameter is use of use. In Hadoop, Java need to be proficient in MapReduce, whereas in Spark, Java, Scala or Python more expressive and intelligent because Spark supports 4 programming languages. The first program and preferable whatever the updation is coming with the help of Scala only. First you can find updation in Scala because Spark written in Scala programming language. So Hadoop supports only Java, need to be proficient in MapReduce. MapReduce is a programming model where a Java program we are executing, compiling, finally we are deploying application. The third one is a data processing. So whereas in Hadoop, data processing is need other platforms for streaming and graphs. That means, so we cannot process at a time streaming data. Streaming data is nothing but flow of data between server to server, system to server, server to system, system to system, flow of flow of data between server to system. That is called data processing. Need other platforms for streaming and graphs in Hadoop environment. Whereas in Spark, data processing by using machine learning library and the Spark measure for streaming data only. That's why GraphX, machine learning library or any other programming languages, Pig, Woozy, Cassandra, Hive, HBase, easily we can integrate with Spark with help of data processing. Then next parameter is failure tolerance. Failure tolerance, I'll give you one example. There are 100 servers are integrated in data center. So both Hadoop and Spark I'm using as a big data processing tools. Whereas in Hadoop, it continues from the point it left off. Whereas in Spark, start the processing from the beginning. because with the help of in-memory computation, if you write once and you are reading many times through a random access memory. So whenever failure tolerance is nothing but if one server is not working in out of 100 servers in a data center, how do we know one server is not working? Based on heartbeat. Heartbeat is nothing but acknowledgement of each data node to the master node. So that is slave node to master node based on the client server architecture. So in a Hadoop environment, it takes continue from the point it left off. Whereas in Spark, start the processing from the beginning. So next parameter is cost. So cost is a very expensive and very important parameter in Hadoop. Hard disk is space cost. We are purchasing number of servers for storing because we are handling real-time environment, huge volume of data. Even Spark memory space is very cost. If our memory is 1 terabytes or 1 zettabyte, then only it can process because every time it loads from the in-memory computation. Next parameter is run. In a Hadoop environment, everywhere you can run in a Hadoop environment, whereas in Spark, it runs on Hadoop because it resembles Hadoop features in a Spark environment. Then next parameter is memory. HDFS uses MapReduce to process data in a physical server. Hadoop distributed file system is used for storage and as well as for processing the and dividing file into number of chunks. Each chunk will take each subnode. So HDFS uses memory. HDFS uses MapReduce to process data in a physical server. Whereas in Spark, this is called in-memory operation. That is called a random access memory. Next one is fast. Fast is a parameter. Hadoop works less faster than Spark because it uses uh, hard disk for load the data set and it runs on batch processing system. Whereas in Spark works more faster than Hadoop, suppose 100 times batch file and 10 times faster than on disk. Next version is, if you see in a Hadoop 2.6.5 release notes, whereas in Spark 2.3.1. Whereas software is a parameter in Hadoop. It is a open source software or reliable, scalable, distributed and computing. Whereas in Spark, it is fast and general engine for large scale data processing. Execution engine, it uses in Hadoop, direct acyclic graph. So tree based structure it uses. One by one task will be executed at a time parallel again. Then Spark uses it is a big data tool in order to execute engine. Big data next parameter is big data frameworks, whereas Hadoop uses a Hadoop concept. In Spark, advanced DAG, direct acyclic graph, support for acyclic data flow, and in-memory computing. Then the hardware cost in Hadoop, you can't imagine such a hardware cost where expensive in Hadoop framework, whereas in Spark very less because of only we are increasing a random access memory concept. Library is a parameter in Hadoop. External machine library we can use in Hadoop framework, whereas in Spark it uses internal machine library concept we can use. Next parameter is recovery. Recovery is a parameter in Hadoop. How do recovery follows in Hadoop and Spark. Easier than Spark, checkpoints are present. See, checkpoints is a special concept. So in Spark supports checkpoints wherever we require, whenever we require, in order to find out what level we have completed the task, whether my system recovered data or not. With the help of checkpoints only we are finding. So in Hadoop, easier than Spark, checkpoints are present. Failure recovery is difficult, but still it is good in Spark. Next parameter is file management system. In Hadoop, Hadoop having its own file management system with the help of Hadoop distributed file system. Whereas in Spark, it does not come with own file management system, because in memory computation there is no concept in random access memory. It supports to the cloud based data platform. Spark was designed for Hadoop. Yes, Spark was designed for Hadoop. So there is no concept of file management system. Everything we are taking from the cloud infrastructure as a service. In cloud based system we are having three types of services. First one is software as a service, second one is platform as a service, and third one is infrastructure as a service. So the next parameter is support. In Hadoop environment system, it supports Hadoop distributed file system because it is a heart of a Hadoop HDFS and MapReduce. So Hadoop YAR, yet another resource negotiator. Yarn expansion is yet another resource negotiator Apache. That means Yarn is a cluster manager. Then Mesos. Mesos is also a cluster manager supported by the Hadoop. Then next Spark. It supports for RDD, means resilient distributed data. If you are taking 1 zettabyte of file as input to the system, once it converted into RDD, it cannot changeable. That means it is immutable. RDD file is immutable. Once created RDD file, you cannot change. That's why it is called immutable. Next parameter is technologies. Technologies in Hadoop, we are using Cassandra. Cassandra is a data warehousing tool in order to process, store huge volume of data with the help of data cubes. We are storing data in a data warehousing with help of data cubes. If you take in traditional database tools like SQL, MySQL, Teradata, DB2, so those relational database tools uses tables schema is a uh, traditional database tools. In order to create a tables, we are using schema or relation or procedure. Then HBase. HBase is a database tool. In order to create unstructured databases, we are using HBase, Hadoop base. Then Hive is a data warehousing tool. In order to store a huge volume of data with the help of data cubes, we are using Hive Tachyon. And any Hadoop sources, these are the technologies we are using. Whereas in Spark, it supports all systems in Hadoop processed by batch system in Spark environment. Next parameter is use places. In a Hadoop environment, how we are going to use places like in marketing analytics, marketing analysis, computing analysis, cyber security data analytics. Whereas in Spark environment, use places are online products. That means Flipkart, e-commerces, any kind of streaming processing like online traffic data, online stock market data, streaming data. That means flow of data between system to system, server to server, or server to system, or system to server. It must be a online product. Then run. Run is a parameter how in a Hadoop environment uses clusters, databases, and server. Whereas in Spark, cloud-based system and data sets, because we are performing online everything in a streaming processing, real-time processing. Whereas in Hadoop, we used to have a batch processing. So that is the major differences between Hadoop and Spark. So the first concept in fourth unit is uh, Spark splits up large tasks across different nodes. What is node? My dear students, please respond me. What is meant by node? Anyone? See, one side I am explaining. There is no communication between us. Hello, madam. Hello. Madam, students are having any doubts, please ask them, madam. What is meant by node? Anyone, please respond. Spark splits up large tasks across different nodes. What is meant by node? Can I call it a server is a node? System is a node? Data center is a node? What is the answer for node? Hello? Yes. Very good. Yes. So node, very good answer. Um, Usually, node is a system, node is a server, and node is a data center. You can call it as collection of nodes. A laboratory means collection of systems. Collection of servers is a data center. Data center is a backbone for cloud computing, for as well as for big data also. However, it tends to perform faster than Hadoop because it uses in-memory computation, and it uses random access memory to catch and process data instead of a file system. Yes, there is no file system concept in Spark. Keep in mind, everything it takes from the cloud-based environment. This enables Spark to handle use cases that Hadoop cannot, because Hadoop uses batch processing for historical and legacy data, whereas in a Spark, it handles real-time and streaming processing data. Next, next concept is lazy evaluation. What is meant by lazy evaluation? In any programming language, Spark supports Python, Java, or Scala. In language theory, lazy evaluation or call by need is an evaluation strategy which delays the evaluation of an expression until its value is needed. Like a plus b within the parenthesis minus a star b within the parenthesis. So based on priority of operators, it will calculate within the parenthesis. First it will calculate based on the programming rules of each C or C++ or Java, Python, Scala, or so that evaluation of expression until its value is needed. That means non-strict evaluation, and which also avoids repeated evaluations in sharing especially. That is called a lazy evaluation. So lazy evaluation is nothing but or a call by need. Whenever you are calling the function or expression is an evaluation strategy which delays the evaluation of expression based on the priority and associativity between operators and operands until its value is needed. That is called lazy evaluation, and which also avoids repeated evaluations, especially in sharing. That is called lazy evaluation. In-memory processing. So what is meant by in-memory processing? Processing in-memory is nothing but we are computing complete task in random access memory. You may get doubt, sir, RAM is a temporary memory and ROM is a permanent memory. So random access memory, when power goes off, usually in system or server, the content will arise. You may get doubt, sir, how it can be processed in Spark, the entire file will be saved, or how it takes how it takes reading many times. We are writing once, but reading many times. See, all the data centers are besides in seashore because it generates a high temperature. That's why they are establishing data centers besides seashore. So, so in data center, you can expect 24 by 7 power. There is no chance of uh, power goes off. Have you seen Gmail account is not working anytime? Because Gmail is a best application and best consumer of cloud computing. It is comes under software as a service application. And if you wake up at 1 o'clock also Gmail works because the service is online 24 by 7. There is no chance of goes power off in the data center. That's why the file is taking reading many times once you are right in memory computation. The integration of processor with random access memory on a single chip. That is the reason in memory processing. The result is sometimes known as a PIM chip. So PIM always computations and processing to be performed within the memory of a computer or server or data center or similar device. So whatever the task we are performing, that is in memory processing. So next concept is DAG. Very, very important. You can expect in the final exam. Explain DAG, direct acyclic graph, with the example. So you need to write DAG is a finite direct graph with no directed cycles. So there are finitely many vertices, means many nodes and edges. Edges is nothing but connection between one vertex to another vertex, one node to another node, one system to one system, one server to another server, the connections. That is called edges, arcs. And where each edge directed from one vertex to another vertex. Vertex here, node. Node is a computer. Node is a system. Node is a server. It contains a sequence of vertices such that every edge is directed from earlier to later in the sequence. If you see in DAG visualization graph, stage 1, stage 2, stage 3, stage 4. That means every iteration, the file load from the Spark, from the hard disk, write once and read many times. That means every iteration stage 1, it performs in stage 2, second iteration, and stage 3, third iteration, stage 4, fourth iteration. So stage 1, one node to another stage 2, it connected edge one node to another node. All the sub nodes are performing all the tasks, data nodes, and it responds to the master node. So it is a scheduling layer in a Spark which implements stage oriented scheduling. Scheduling, that means stage oriented scheduling is nothing but every iteration, every stage it performs a task with parallel environment. In HDFS, the file load once and it divided into number of chunks. Each chunk will take each subnode with parallel environment. It converts logical execution plan to a physical execution plan. That is called indirect acyclic graph. It when an action is called, that means some action we are performing in stage 1, stage 2, stage 3, stage 4. Spark directly strikes to DAG scheduler. So it is performing stage by stage, stage by stage. So it executes the tasks, those are submitted to the scheduler. So in parallel environment, the file is executing in parallel manner. Whatever the task we are assigning to the each node, it is performing according to our instruction of a program where in Scala or Java or Python or R programming, it executes the tasks. Those are submitted to the according to the scheduler. That is called a direct acyclic graph. The next concept is Spark context. See, whenever you are executing a program in Spark, so first it creates an environment called Spark context in Apache Spark. So a Spark context represents the connection to a Spark cluster. So a group of servers is called a cluster. You know what is meant by cluster? Cluster is a collection of a group of servers with similar task, similar behavior. So how do you create a similar similar measure between clusters based on Euclidean distance, similarity measure usually in clustering concept, Minkowski distance, Euclidean distance, and so we are using similarity behavior of each cluster, and it can be used to create RDDs. So resilient distributed data, whatever the data input, suppose you are giving stock market data is input to the system. So stock market data in a CSV file format, you have collected online through streaming processing data. So every second data is changes in share market. That is called streaming data. So once you converted into with help of transformation or action, it becomes RDD. So that RDD is called a data set that is immutable. Once you created a data set into a RDD with help of transformation or action, it became RDD file that is called immutable. So whenever we are it represents the connections to a Spark cluster. It accumulators and broadest variables on that cluster. It uses automatically how many executors we are using. Suppose, uh, see, how do we know how many executors we are using particular application? How much memory we are using particular application? That we come to know with the help of Spark context. SC dot parallelize. See, SC while writing a program in Scala or in any programming language, we used to write data is equal to X some transformation followed by the SC dot parallelize. SC here nothing but Spark context. SC dot parallelize. I am using 4 executors while performing any task. Okay, so see by default 64 KB. I am dividing file into number of chunks, or in high computing servers we are using 128. Some systems uses 256. Some systems uses 512 KB. Some systems uses 1 MB. Each subfile can be divided into. So by the time how many accumulators we are incorporating in this Spark, how many broadest variables on that cluster we are using. Maybe yarn, maybe mesos. These are the cluster managers we are using in Spark. So note, only one Spark context should be active per JVM. That means Java Virtual Machine. If you are using Java in programming language, so it is a platform independent. So automatically each system can execute its own JVM environment. It creates bytecode. That bytecode you cannot understand. The system can understand that bytecode. Bytecode is nothing but a stream of collection of bits that is called bytecode. You must stop the active Spark context before creating a new one. See, for every application, we are using by default executors and by default memory. How much memory you are using for application? By default, I'm using for each subtask 64 KB or 128 KB or 256 or 512. Depends on your computing power. The active Spark context before creating it, new one you need to stop. This is about the Spark context. You see here in the diagram, I'm taking one application like stock market application as a data input set. I am giving as a CSV file format, comma separated variable as input to the system. I am applying transformation, converting one file format to another file format. So then it becomes RDD file. RDD file is nothing but immutable. You cannot change any particular row or particular column or particular task. So then it comes to the driver program, that is where we are using Spark context. See here in yellow, Spark context, that is called sc.parallelize. Now after giving application as input to the system, driver program take into the action with the help of sc.parallelize. Here Spark context we are using. It represents connection to a Spark cluster. Maybe you are using yarn, yet another resource negotiator, or mesos cluster manager. So in cluster managers, maybe yarn or mesos. So in cluster manager means a group of a collection of similar behavior data stores in that each cluster. So it can be divided into number of executors. So depends on your application, you are dividing number of executors and you are dividing number of memory for each task, how much default memory it requires. So executor will takes the parts like cache in memory computation and it will perform the each task. So that is called worker node. So worker node takes as executor, each executor, and how many executors we are creating, that is depends on a cluster, I mean master slave architecture. Suppose I am creating one master with 100 slave nodes I am creating in order to perform task in parallel environment. So that is in a Hadoop distributed file system concept. So functions of Spark context in Apache Spark, if you see, what are the functions it is going to perform? Functions of Spark context in Apache Spark. See here, get the current status of application, first one. The first function, you know function, uh, can anyone explain how many functions we are using in Spark context? Yesterday, you might have seen one function in Scala programming. Usually in a map reduce model, suppose I'm using, there are various functions I'm using like, can anyone list out what are the functions we are using in map reduce? Yesterday I have explained. My dear students, please respond. Map reduce. What is meant by map reduce? What are the functions are available in map reduce? Suppose you are using Java programming. Suppose you are using Scala programming. Madam, any student? What is meant by function? What are the functions of Spark context in Apache Spark? Suppose you are using Java or Scala programming languages. Function is nothing but self-contained block of statements to perform specific task. In a programming model like map reduce, it uses a map is a function, reduce is a function, shuffle is a function, aggregation is a function. So the first function in Spark context, get the current status of application. Then that means we are loading data into the system in Spark. Second function is set the configuration, means how many executors, how much memory by default in Spark, how many client nodes and master node and slaves. Then third one is a cancel a job. I can perform one more function, cancel a job. It is a function. What is meant by function? To perform any specific task is called function. How many functions we can perform in Spark context? These many functions. Cancel is a cancel a job. It is also a function. Access various services. It is a function. So closer cleaning in Spark. I'm closing that particular task or particular executor. Then programmable dynamic allocation. I'm allocating some memory to particular node, particular executor, particular data node. That is called one more task. Seventh one, register Spark listener. See, so whether I'm getting a heartbeat from the data node or not. So that shows the fault tolerance of a particular system Hadoop or Spark. So register Spark listener is a function of Spark context. So unpersist RDDs. Unpersist RDD is nothing but how many immutable files are presented, and I'm counting that function. So with how many RDD file supports to the Spark function, Spark context. So unpersist is nothing but how many are not supporting or not performing any task in the Spark context in Apache Spark. That is also one of the function. Then cancel a stage. See, we are creating number of stages in cluster manager based on executor and task in a data node. So cancel a stage is also one of the function in a Spark context. Then access persistent RDD. How many RDD files I have created? I'm counting and accessing. So accessing is a one more function of Spark context in Apache Spark. These are the various functions of Spark context. Next one is Spark session. So Spark is a framework and part in Hadoop because it resembles Hadoop environment. It uses HDFS and MapReduce major components in Spark session, but it deals with only streaming and real-time processing. Spark session is a unified entry point of a Spark application from Spark 2.0, that is version. Okay, so first we are loading a data into the system. So for each file can be divided into number of subparts, and then we are starting with a program in Scala. Then we are using Spark session. So whenever you are creating sc.parallelize means you are allocating automatically Spark session. Spark session consists of Spark context like sc.parallelize means master's slave architecture, master node giving a task to the slave nodes acknowledge each task is completed. So here for core API, application programming interface, a Spark context, streaming context, SQL context, I can create various input files for different streaming files in a Spark session. That is the beauty of number of unstructured data files I can create, and I can apply a transformation or action. I can create the RDD file with the help of Spark context in parallel environment. So that is called a Spark session. So Spark session is a unified entry, actually point of a Spark application from Apache Spark. Then RDD. RDD is nothing but resilient distributed data. So RDD was the primary user facing API in Spark since its inception. Inception means the first stage. See, I have created Excel file or CSV file of stock market data. Take stock market data. So serial number, name of the share, and cost of the share, and name of the company, name of the share, and total price, and like that. Number of parameters, number of columns in a data set, maybe Excel or CSV. So once I am loading CSV file into the Spark system, that is called inception. Spark, since its inception, at the core, is nothing but it can support for Spark SQL, okay, and it supports for GraphX, it supports for Scala programming, it supports for HDFS, it supports for MapReduce, anything. So an RDD is an immutable distributed collection of elements of your data. Yes, once created a data set to the file becomes RDD. It is immutable in distributed collection of elements of your data. So it is partitioned across nodes. Yes, the file is divided into number of subparts, and each subpart takes data to the each node in your cluster that can be operated in parallel with a low level API that offers transformations and actions. Once you are loading a data into sub nodes from the client server architecture, so then we are performing various operations in transformations like flat map. Okay, we are performing various operations in actions like collect, count by key, reduce, various actions we are performing on a RDD file. Resilient distributed data. The expansion of RDD is resilient distributed data is the fundamental data structure of a Spark. Yes, it is a fundamental data structure. You know data structure? Why do we want to use data structure? It is a prime and core subject of IT and CSE. Can any student, how many types of data structures we are dividing? Any student, why do we want to use data structures? Why we are using data structure? Can any student can respond with the answer? Hello. My, yeah.
To store data in a
Fantastic.
certain way.
Very good. Only storing?
To also access it properly as we need.
Yeah, very good. Only storing, only accessing. Few more answer I'm expecting from you. Why data structures? Very important question for final interview. I mean technical interview. If you are in final year, definitely they will touch data structures concept. Why we are using data structures? She told two answers, correct answers. Storing the data and accessing the data. Have you think of why we are using data structures? Data structure is a systematic representation of data organizing data, storing the data, representing the data, and accessing the data in any form like linear fashion or non-linear fashion. If you are using linear fashion, so we are using stack, queue, linked list concepts. If you are using non-linear fashion, we are using trees and graphs concept. So be strong in data structures. See, suppose you are a final year student, every interviewer expecting from you one front end language, any one front end language like C, Java, Python, C++, any one programming language mandatory for you. You must be aware of one programming language must be front end language and one back end language, anyone, SQL or MySQL or Teradata or DB2 or MS Access minimum. You must be ready one database language, one front end language, one back end language. Then operating system, any one operating system like Windows or Linux, you must be perfect. Three subjects are mandatory for any candidate for an interview. So the front end you can use any C or C++ or Java, Python. Any one language must be perfect. Any one backend language, SQL or MySQL, you must be strong. Then you must be ready with operating system concepts. If you are having additional knowledge like this, you are so lucky enough. Satish sir explained data tools and techniques, latest subject, big data, cloud computing. So you are outstanding for interview panel. So definitely they'll touch on big data and data analysis tools and techniques, various concepts. So here in RDD, the fundamental step is data structures. It uses RDD is the fundamental data structure of Spark. They are immutable, distributed collection of objects of any type. Yes, as the name suggests, is resilient, means fault tolerant. I have explained what is meant by fault tolerant. Can anyone explain? Can anyone respond? What is meant by fault tolerance? Please. Hello, my dear
Whenever
students. Yeah, please respond with your
whenever any kind of error occurs, it is able to revive itself from that
fantastic answer. What is your name?
Shravani.
Shravani. Give her a big round of applause, all of you. So that is a fantastic answers. I'll give you once again. Fault tolerance is nothing but you have a data center. In that data center, 100 servers are there. What is meant by data center? Collection of high integrated servers at one place is called data center. So out of 100 servers, one server is not working. It is not giving heartbeat to the master node. Immediately it it acknowledges to the master node. I means our master node knows that one server is not working. One data node is not working properly. So by that time, the system cannot stop. It resumes still. It continues giving service 24 by 7. That is special concept called resilient. That is called fault tolerance. Very good answer, Amma. Keep it up. So, so RDD name suggests it records of data that resides on multiple nodes. That resides on multiple nodes. So RDD is a fundamental data structure of a Spark. It is an immutable distributed collection of objects. So each data set in RDD is divided into logical partitions. So which may be computed on different nodes of the cluster. Yes. So it is divided into logical partitions, which may be computed on different clusters with different nodes. Okay, that is called RDD. Next, what is meant by transformations? See here, transformation is nothing but converting a file one format to another file format is called a transformations. So there are two types of transformations, narrow and wide. Narrow transformation, okay. Um, See, you can take example map and filter. Okay, it performs a small task in Apache transformation. So there are two types of operations. In narrow transformations, we are using map and filter. In wide transformation, all the elements that are required to compute the records in the single partition may live in many partitions of parent RDD. So see examples of narrow transformations, map, flat map, map partition, filter, sample, union. See, I'm going to show you or I'm going to demonstrate all narrow transformations and as well as wide transformations. Wide transformations are required to compute the records in the single partition may live in many partitions of parent RDD like group by key, joins. We are using in wide transformations, group by key, join with inputs. Okay. So now I am going to explain each transformation in Spark environment. See, if I am explaining continuously theory part, you will feel bored. Now I'm going to demonstrate or I'm going to explain um, each transformation. Please, you can solve this one. Okay. Okay. See, practice on Spark transformations. I'm going to demonstrate now. Map, filter, flat map, group by, group by key, sample, union, join, distinct, key by, partition by, and zip. Now I'm going to demonstrate each one transformation. Please see, before going to transformations, see here, resilient distributed data is a main logical data unit in Spark. We used to call it as a data set. Don't assume RDD, I don't know RDD. Don't feel like that. RDD is nothing but, suppose you are taking a data set. What is meant by data set? Data set is a collection of rows and columns. What are the rows? Suppose in your class 120, 60 students are there. So I'm creating IT students one data set like a serial number, name of the student and roll number, email ID and marks and average, total and pass or fail. These are the columns, attributes and dimensions I'm taking a IT data set. It is in Excel file format. Now I'm taking 60 students, roll 1. I mean serial number 1, name Shravani, roll number 1201, and section B, marks 85% and total marks, then average, then result. This is one row. Like that I am filling 60 rows. That means 10 by 60. So, so 10 students, I am creating a number of columns like 10. 10 into 60, 600. So number of instances 60. Instances is nothing but rows. Rows are also called as a tuples. Tuples are also called as records. So file is a collection of records. Each record consists of some instructions, name, roll number, etc. So resilient distributed data is a data set, is a main logical data unit in Spark. And RDD is a distributed collection of objects. Okay. So transformations are lazy evaluated operations on RDD that create one or many new RDDs. Example, map, filter, reduce by key, join, co-group, random split, etc. Transformations are lazy, that is, are not executed immediately because it follows some rules and regulations on priority or associativity. I have taken one expression a plus b within the parenthesis minus a multiplied by b. This is the expression. First, it will execute within the parenthesis based on the associativity and the priority. It will execute priority of the operators. So that's why it is called a lazy evaluation. In any programming language, it follows rules and regulations. Transformations can be executed only when actions are called. Yes. Okay. The first one, see here, all of you. Map. Map is a transformation. I'm giving the meaning of map. So map is a transformation. It passes each element of the RDD through the supplied function. So map is a transformation function. Keep it aside. I'm explaining first example. I'm taking a data set. I'm declaring val space x is equal to, okay, x is equal to array of b comma a comma c. You can use single quote or double quotes. Okay, so I'm declaring array data set b comma a comma c. Now value, see x is the input data set. I'm taking as array data set which consists of b comma a comma c are the elements. Now y is the output variable. I'm performing a Spark transformation. X dot map of, I'm showing example, z is equal to z comma 1. According to this output, it has to transform a data set X into required output is called y colon. I'm getting the output y colon b comma 1, a comma 1, c comma 1. Why? Why it gave a y? Because I am performing map transformation. I am showing example z is equal to z comma 1. Based on this example, my data set will be mapping with the output variable y. So y gives output b comma 1, a comma 1, c comma 1. So now I am demonstrating this one. You can use any online compiler, or if you are using any, uh, suppose, do you have a laboratory? Hello, madam. For them, students having any laboratory for data.
Yes.
So they may be having in their laptop, because I haven't installed in this one. This is a new laptop, madam. Yesterday only I came. One
Sir,
second.
do it with an online comparison.
Yes, yes, madam.
Everybody are using online compilers, sir.
Yeah, they can, if they have their own system in Scala, they can execute.
Somebody brought their systems and they've gone through online compilers.
Okay.
They are all sitting in the auditorium, sir. So that's the reason.
Oh, sorry, sorry, sorry. Yeah, yeah, yeah. So yesterday they have executed in online compiler. Sir, did you share this PPT to them, sir?
Yes, sir. Yesterday's PPT was shared to them, sir.
Sir, today PPT also share, sir. Shall I
Definitely.
send to your WhatsApp? I'm sending to your
Yeah.
WhatsApp. Please share.
Yes, sir. Please send it.
Yeah, now I'm sending, sir.
Thank you, sir.
Sir, you have a group na, sir, so that they will get it immediately.
Yes, sir. Yes, sir. Otherwise, you
Yeah,
can send it
I'm
to
send-
Satish sir also.
Yeah, I'm sending. I'm sending, sir. Yeah, I'm sending to
Please send it
Satish, sir.
Satish. Yes.
Satish, sir. Sir, I have sent to Satish, sir. Sir, please share with the students, sir, so that they will execute.
Okay, sir. Okay, sir. Hello.
Sir, please check your WhatsApp, sir. I have sent.
Okay, sir. Okay, sir.
So this is a Scala program. Yesterday we have executed. Okay. So 1 second, sir. I have sent to Satish, sir. Please. So now see the explanation of you can execute your own style, no problem. So what is the output of this? You can execute one line by line. Okay. So I'll explain, then later you can execute because now time, how much time still? Okay, 11:16. Sir, can we give a break 10 minutes, sir? Because next 1.5 hour will take complete session, sir.
Definitely, sir.
Yeah, please.
After 10 minutes. After 10 minutes, you can
Yeah.
give the break.
Yes, sir. Please give 10 minutes time, sir.
Sure, sir. Sure, sir. We'll start the session at 11:30, sir. Again.
Yes, sir. Please.
Okay.
Hello, madam. Hello. Hello, madam.
Yes, sir, you're audible.
Yes. Shall we start, madam?
Yes, sir, yes, sir.
All students came.
Yes, sir.
Okay, madam. Madam, they have executed this program, Scala programming, last class.
Yes, sir.
Yes. Okay. I think they can do. I think I'll give explanation because
Sure, sir.
syllabus also there. So that yeah, 1 second, madam. So next second program is write a scalar program to perform addition of two numbers using dynamic input. So that we are reading through keyboard and we are performing same same online Scala compiler. You can execute this program and Scala program to print numbers from 1 to 100 using for loop with until to determine loop range. So here also we are using 1 to 100 to print Scala program. Then Scala program to print largest number among two numbers. So this is the same. We have used a relational operator number one greater than number two. We are printing this one also. So these programs you can execute in through online compiler and you can do your own program also. Once you learn the environment, you can execute your own programs. So the first function is in transformation, map transformation. I'm taking X data set B comma A comma C and Y is the output variable. I'm performing transformation X dot map. X is a input data variable array data set and dot map X dot map it perform transformation. I'm converting into output variable like z comma 1. I'm showing one output variable. According to that one, I'm splitting each one B comma 1, A comma 1, C comma 1. So in the diagram also see here map is the transformation that takes a function and applies the function to each element of the input RTD. The result of the function will become the value of each element in the result RDD. See here, input RDD, I am taking data set 1, 2, 3, 4. I am performing a map function x multiplied by x. So that means 1 into 1, 1, 2 multiplied by 2, 4, and 3 multiplied by 3, 9, 4 multiplied by 4. That is 16. This is the map function. One second. Okay. So next one is a filter. So filter is a transformation. So it is a transformation that returns a new RDD with only the elements that passes the filter condition. See here, I'm taking input data set val x is equal to sc dot parallelize of array of 1, 2, 3 and value of that is the input data set I am taking. So spark context sc means spark context dot parallelize. So I'm taking array data set 1, 2, 3. Y is equal to x dot filter. So I'm doing filter transformation. X dot filter n is equal to n modulo division by 2. Exactly equal to 1. That means so modulo division operator gives always reminder. So 1 modulo division by 2 reminder 1, 2 modulo division by 2 reminder 0, 3 modular division by 2, remainder 1. That means whenever you are performing modular division operator, it gives only 1. So those values will be gives the output. So I'm printing println of y dot collect. Collect is a action and dot make string. I'm printing that value 1 comma 3. Take one more example. See here see in this filter is a transformation. Keep in mind whatever the values gives 1 out reminder. So for that one it will print. So filter is a transformation that returns a new RDD with only the element that passes the filter condition. See here in this example below the diagram, I'm taking input RDD 1, 2, 3. Now I am applying filter function. X implies X not equal to 1. See 2 and 3. Resultant value is 2 and 3. So if X is equal to 1 means it will return 1. X not equal to 1 means 2, 3. That is filter function. Next flat map. Flat map, see here I am using flat map function. Value X is equal to sc dot parallelize. What is meant by flat map? So it will apply on the entire data set. Is the transformation that it takes a function and applies the function to each element of the RDD as in map function. Now see value X is equal to sc dot parallelize array of 1, 2, 3. I'm taking a data set X. Sc dot parallelize of array of 1, 2, 3. Now value output variable y is equal to x dot flat map of n implies array of n comma n n multiplied by 100 comma 42. This is the output variable I am giving. Now I am printing that value like println of y dot collect dot mk string. So I'm printing according to the output variable example flat map I'm performing. My data set is 1, 2, 3. Now first iteration. See 1 n is equal to 1, then n 1 into 100, then 1 into 42, it will print as it is. Then second iteration, see here, n value is 2, 2 multiplied by 100, that means 200, then 42 as it is. Then third iteration, third value, I mean in the data set third value, n is equal to 3, 3 multiplied by 100 and 42. This is the output variable. This is called a flat map. Okay. So in the example, you can see here input RDD is a hello world, comma, how are you? Now I am performing a flat map. X is equal to x dot split. Split is a transformation function. Resultant value is hello world, how are you? This is called a flat map function. Next, fourth one, group by. So see here. So when on a data set k comma v pairs, return a data set of k comma iterable key value pairs, group by key. Now input value x is equal to sc dot parallelize. Array data set consists of John, Fred, Anna, James, 4 names. Then value y is equal to output variable y is equal to x dot group by w is equal to w dot character at 0. Now I'm printing that output variable y.collect.mk string. Now group by is a transformation. It is performing the action according to the output variable. That means word count at 0th position. For every string, the first position is uh, J, F, like that. So it is performing the group by function. So A with Anna, J with John and James, F comma Fred. So group by means how many strings are there? The first letter which starts with J, how many strings are there? Remaining all are one. A comma Anna, correct. J comma John and James, correct. Because J with in first position, J is presented. Then F is equal to Fred. This is the output of group by. Next transformation, group by key. So group by key is a transformation. It returns a data set of k comma key value pairs. You can call it as a key value pairs. Okay. Value x is equal to sc dot parallelize of array comma b comma 5, b comma 4, a comma 3, a comma 2, a comma 1. So these are the transformation. This is the x data set. Okay, x data set I am taking as b comma 5, b comma 4, a comma 3, a comma 2, a comma 1. Now output variable y is equal to x dot group by key. Now I am performing group by key. It is a key value pair. It is a key value pair. It is a key value pair. Now see, I'm printing. So A with how many numbers are there? 3, 2, 1. Then B with how many numbers are there? It is working with the group by value. I mean uh, key value pair concept. Keep in mind this group by key function follows the key value and key value pairs. Now A with 3 comma 2 comma 1, correct. B with 5 comma 4. This is the output of group by key. Next. Sixth one, sample. Try to listen this one, sixth one. Sample is a transformation. So usually sample works on a data set, especially in statistics. Sample generates every time random generation. Sample is a transformation. It generates values every time in random values generation. I'm taking value x is equal to, listen carefully, x is equal to sc dot parallelize of array of 1 comma 2 comma 3 comma 4 comma 5. I'm taking as a input data set x. Then y is equal to x dot sample of false comma 0.4. Now try to understand what is the meaning of a sample here. X is an input variable, y is an output variable. X dot sample false comma 0.4 means 40% of x values. Now how many x values are there? 1 comma 2 comma 3 comma 4 comma 5. That means 5 values are there. 40% of 5 means 2. That means 2 values. So every time 2 values will be generated randomly. That is called a sample. 40 false means remaining 60% values are correct. Only 40% false value can be generated in this data set. So the output value is it is omitting seed value yielding different output, like 40% of x means two values. Suppose 2.3, 2.4 means we are omitting seed value yield different output. So finally I'm printing the value 1 comma 3. Not only 1 comma 3, it can generate random values, sometimes 3 comma 4, sometimes 5 comma 4, 4 comma 5, 2 comma 3, 3 comma 2, like that. Any random value can be generated with the help of sample transformation. My dear students, please ask me any doubt in this sample transformation. Anyone, you have any doubt, please ask me. Sir, where we are using this sample transformation. So we are using this sample transformation while conversion of Excel data with numeric values. I want to find out only 40% of that X value. So my X is 1 comma 2 comma 3 comma 4 comma 5. Now I am expecting output variable Y. Okay, false indicates means only 40% of given X values. So 40% of 5 values means 4 5s are 20 means 2, 2.0. So 2 values I'm taking as a random generation every iteration. Maybe 3 comma 4, maybe 3 comma 2 sometimes it can generate. Okay, that is called a sample transformation. Next, union. Union is a transformation. Okay, return the union of two RDDs. Now I'm taking first RDD value input variable. Why, what happened? Hello, madam. Hello, sir.
Hello, sir.
My voice is audible, madam.
Yes, sir. Yes, sir.
My screen is visible.
No, sir, no.
Yeah, that's the reason I got some interconnection problem, madam. Internet.
I'm screen until now. I'm concentration screen. Sir, sir, is it it's visible now?
Yeah. Okay, madam. Union is a sample. My voice is audible, madam.
Yes, sir.
Madam.
It's audible.
Yes, sir, you're audible.
Yeah, thank you, madam. So union is a transformation. It is very simple. It returns the union of two RDDs. My X is the input variable. SC dot parallelize of I'm taking array of 1 comma 2 comma 3 with two sets. So 2 indicates here 2 sets. Then output variable Y is equal to SC dot parallelize of array of 3 comma 4 comma 1. See, I am showing the output variable like how many sets I am going to divide the given input X value. So 1 comma 2 comma 3 or 2 sets. So I am showing the final output simple array of 3 comma 4 comma 1. Now I am performing the action Z is equal to X dot union of Y. Two input variables I am taking here. X and Y are the two input variables with two data sets. First data set is 1 comma 2 comma 3 are the two sets. 3 comma 4 is one set. Now I am performing the transformation Z is equal to X dot. So X dot union of Y. So usually in mathematical terminology X union Y. Same way here. So Z out. I'm using a output variable. So first iteration 1 it will come, then 2 comma 3 then 3 comma 4. So these are the two sets I'm getting. So I'm doing union operation. That's why I'm getting these values first. So x, so 1 set, and 2 comma 3 2 set, and 3 comma 4 2 set. So union, no need to use the redundant values. Whatever the values are there, it will give the output union. It returns two RDDs. Then if you see the join, if you have a join data set, this will be easy. It's joining of two data sets. Join is a transformation function. It performs value. Suppose I'm taking x and y are the input variables. Sc dot parallelize of array of a comma 1, b comma 2. Okay. Then y is equal to sc dot parallelize of array a comma 3, a comma 4, b comma 5. This is a y input data set. X is a input data set. Then final Z output data set is equal to x dot join of y. Now I am joining two data sets. Here join is a transformation function. It joins two data sets. So now the output variable, it will print like, so you see print z dot collect dot mk string with a comma. Now I'm using separated with the comma. So with A, how many numbers are there? Please check in the X and Y input data sets. A with 1 comma 3 is there, 1 is there. A with 1, A with 3 is there. Yes. Then A with 1 comma 4 is there. Okay, joining. And B with 2 comma 5 is there in X and Y input data sets. You understood? So A with 1 comma 3, then A with 1 comma 4, then B with 2 comma 5. See, check in the X and Y input variables. So B with 2 is there, in Y variable B with 5 is there. Now I am combining, I am joining two data sets, A with 1 comma 3, then A with 1 comma 4, then B with 2 comma 5. This is the join function works. Next data set, distinct. What is meant by distinct transformation? Distinct transformation means it gives distinct values. It gives distinct values like x input I'm taking sc dot parallelize. Okay. So my array data set distinct, if you see distinct, written a new RDD with distinct elements within a source RDD. So value x is equal to input value I am taking 1 comma 2 comma 3 comma 3. 2 times 3 came here. Please observe. Then 4. But output variable y is equal to x dot distinct. Output variable y is equal to x dot distinct. So distinct is a transformation. It eliminates redundant values. So println y dot collect dot mk string separated with the comma. So output y value 1 comma 2 comma 3 comma 4, because 3 is repeated twice. It will eliminate whenever you are transforming distinct transformation function. Now the output is 1 comma 2 comma 3 comma 4. I think everybody understood. Then key by. Key by is a transformation function. It returns a new RDD with distinct elements within a source RDD. Okay. Now X value I am taking as input. SC dot parallelize of my array consists of John, Fred, Anna, James. This is the input data set I have taken, and output variable y is equal to x dot key by x dot key by. I'm applying transformation function key by. I'm showing the output variable w is equal to w dot chart at char at 0 means first position. So print ln y dot collect dot mk string. So first character 0 with how many strings are there? W dot char at 0th position. Now output variable y is equal to J with John. Yes. First letter J with John is there. Then F with Fred. So only one string is there. F with Fred. Then A with Anna and J with James. This is output of the key by. Okay. Next, zip. Zip is a transformation. It joins two RDDs by combining the ith of either partition with each other. So join is a transformation function. It joins two RDDs. It joins two RDDs by combining the ith of either partition with each other. Now I am taking x input variable sc dot parallelize of array of 1 comma 2 and y input variable x dot map of n is equal to n multiplied by n. Now I am expecting output variable z is equal to x dot zip of y, means according to the output variable y n square, n into n means n square, it will print the values. So 1 multiplied by 1, so 1, and 2 multiplied by 2, suppose you are giving input 2, so 2 multiplied by 2, then 3 multiplied by 3. So this is about a zip transformation. Keep in mind, zip is for maximum, I mean uh, zip joins to RDDs. Okay. Now see here, that's why I'm getting the output value is 1 comma 1, 2 comma 4, 3 comma 9. Next. Next, task 2. You can practice in the laboratory session also, or you can use any online compilers, because this syllabus is a little bit vast. That's why I'm giving explanation. So practice on Spark actions. So 11 transformations we have executed. Now I'm going to explain 10 more actions. That is get number partitions and then collect, reduce, aggregate, max, sum, mean, standard deviation, count by key, like that. Okay. So RDD is nothing but a resilient distributed data, is a main logical data unit in Spark. And RDD is a distributed collection of objects. Actions returns final result of RDD computations or operation. See, why do we want to use actions? Actions are returns final output of two RDD components. So action produces a value back to the Spark driver program. It may trigger a previously constructed lazy RDD to the evaluated. Okay. So you can, 1 second. So action function materialize a value in a Spark program. So basically an action is a RDD operation that returns a value of any type, but RDD is an action. Okay. So if you see, first one is a collect. So collect returns the elements of the data set as an array back to the driver program. Keep in mind, it collects, returns the elements of the data set. What are the elements of the data set like X of the data set as an array back to the driver program. Now I'm taking X as input to the system sc.parallelize of array of 1 comma 2 comma 3 with two sets. Okay. So now I'm printing the value of X. Y is equal to X dot collect. So in collect is a action on perform, we are performing on X. Now it is printing the output variable. It returns the elements. How many elements are there in this one? So if you take in first set 1 comma 2 comma 3 and the second one is 2, but it returns 1 comma 2 comma 3. Even though 2 is presented 2 times, but it will print only. I'm asking print, that's all, correct. So redundant value it cannot print. So 1 comma 2 comma 3. Next, reduce. Reduce is an action. Aggregate the elements of a data set through function. So summarize. Aggregate means summarize the elements of a data set through functions like reduce. Okay. So input variable val x is equal to sc.parallelize of array of 1 comma 2 comma 3. So input variable is x with values like 1 comma 2 comma 3 comma 4. Now output variable y is equal to x dot reduce of a comma b. So it implies a plus b, uh, sum of values. Now output variable y is equal to 1 plus 2 plus 3 plus 4 plus 5. So that's why it is getting 10 value. This is called a reduce action. Next, aggregate action. Aggregate is a action that allows the user to apply two different reduce functions. The user to apply two different value functions to the RDD. Two different reduce functions to the RDD. Now see here X input value. I'm taking a value input RDD. That is a variable name. Input RDD is equal to sc dot parallelize of list. I'm consists of maths 21, English 22, science 31. Like that, three sets are there. So next value result. Value result is equal to input RDD dot aggregate. Now I'm aggregating three values. So access comma value. So I mean account. You can call it as a account. Okay. So I'm adding all account 1 and account 2 values here. First iteration, how it does aggregate function. See, very simple. Aggregate is a action. It allows the user to apply two different reduce elements. Okay, two different reduce elements to the RDD. So now first iteration, partition 1, what will happen? Sum of all elements plus 3 of 0 values. Next, partition 2, sum of all elements plus 3 0 value. Partition 3, sum of elements third time. Now finally we are combining, that means aggregating. Combining of partition 1, partition 2, partition 3 and partition 0 value. Now here, so we get 21 plus 22 plus 31 plus 4 multiplied by 3, 12. Now the output value of value result is 86. Output value is 86. If you add 21 plus 23, 43, 43 plus 31, okay, 74 plus 78 plus 12, I mean 74, you can add that one, 12, 86. So this is output of aggregator action. Next, max. Max is a action. Max is a action. It returns the largest element in the RDD. Now see input variable value x is equal to sc dot parallelize array of 2 comma 4 comma 1. Then y is the output variable. Y is equal to x dot max of x. I mean y is equal to x dot max is a action. So x value is 2 comma 4 comma 1 and y is equal to x dot max. So it will print large value 4. Next, so count number of elements in the RDD. Value x is equal to sc dot parallelize array of apple comma bread, apple comma bt and Beatrix. So that is x input value and y is equal to x dot count. So now the output value is how many are there? Apple 1, BT2, Beatrice 3. So it will give count number of variables, number of values in the X data set as input. X is an input data set with 3 items. Apple, Betty and Beatrice. So count function works properly. 3. Next, sum. Sum is a sum of the RDDs. Sum is an action. It performs various sum operations like 2 comma 4 comma 1. So if I can add 0 to numbers, total numbers like 2 comma 4 comma 1, 2 plus 4, 6, 6 plus 1, 7. So that is called a sum action. Next, mean. Mean of given RDD. Mean of given RDD. So my value x is equal to sc dot parallelize of array of 2 comma 4 comma 1. So value y is equal to x dot mean. I'm performing mean. So mean value. So 2 plus 4, 6 plus 1 by 2, 3.2.33. So this is input value of x and y, 2.33. Next, standard deviation. An aggregate function that standard deviation of a set of numbers. So we know how to do standard deviation in mathematical. Now I'm taking x as an input to the SC is equal, I mean value X is equal to SC dot parallelize of array of 2 comma 4 comma 1. Now I'm performing Y is equal to X dot standard deviation. So usually I'm getting Y is equal to 1.24, 1.24. That is a standard deviation function. Count by key. So this is only available on RDDs of key comma value, key value pair, and returns a hash map of k comma count of key, hash map. Okay, so hash map, I think everybody knows hash index table in data structure. Hashing is a process of mapping key with value pair. So elements are competing for hold same bucket. Suppose two elements are competing to hold same bucket, that becomes a collision. To avoid the collision, we are using various collision resolution techniques like chaining technique, hashing technique, double hashing technique, etc. So count by key. This is only available on RDDs worked on a key value pair. So output variable X dot count by key. Now you can check J comma James array of array data set I'm taking. Then F with Fred, A with Anna, F with John, J comma John. Now value Y is equal to X dot count by key. See, you need to count A with 1, F with 1, and J with 2. This is the output variable of count by key. Next, get numbers. Value X is equal to SC dot parallelize of array 1 comma 2 comma 3 comma 2. 1 comma 2 comma 3 comma 2. That means value Y is equal to X dot patterns, I mean X dot partitions dot size. So value Y is equal to X dot partition. How many partitions? I am dividing 2. So definitely it will give output 2. So with this one, I'm closing the transformations and the functions. Now see Hadoop versus Spark. Before going to this one, please do favor for me. 5 minutes. Please open all of you your system. Hello, madam. Please instruct them, madam. I have given. Hello, madam.
Yes, sir. Yes, sir. They are opening.
Yeah, please open. I have given with execution a Spark transformation and actions. Please open all of you YouTube. I'll show you which video you can listen at evening time. Okay. I'll give you name of the video so that there I have executed all transformations and executions. I mean all transformations and actions. Please open all of you YouTube. Sir, how many students are there, sir?
Nearly 150.
150. Please, yeah, please open YouTube and type my name, sir. Please instruct them, sir. I'll give them my video name.
Okay, sir.
Yeah, please 5 minutes. Do favor for me.
Definitely, sir.
Just type my name, Dr. Asadi Srinivaslu, YouTube channel. Please type all of you. So there is a, you type my name, Dr. Asadi, ASADI, subscribe and then see the video name, Big Data Analytics using Spark. 2 hours, 15 minutes is there. So 1 month ago, like 17, see, last but one, Big Data Analytics using Spark. Please open all of you YouTube channel. First do subscribe. I'm giving time 5 minutes. Please open all of you YouTube. There you type Dr. Asadi Srinivaslu plus YouTube channel. Please subscribe now. Please subscribe now and see the video. Please do all of you. So my dear students, please subscribe and see the video. Just 5 minutes. If you are having headphone, just 5 minutes. Big data analytics using Spark. Evening time you can listen that 2 hours video. If you have any doubts yesterday and today's concepts, again you can listen this big data analytics using Spark. Please do all of you subscribe and see the file name is Big Data Analytics. Big Data Analytics using Spark. Big Data Analytics Spark. Last but one, last uh, uh, the file name is Big Data Analytics using Spark is there, and various technologies are there. Still, I am uploading 150 videos are there on data science. Okay, and on artificial intelligence, on data science, machine learning, and deep learning, cloud computing, and various technologies I have explained in all over the globe, various universities, and in industry also I am doing corporate training. Those videos are not available right now. I am going to upload today or tomorrow. Nearly 100 videos are there related to all the latest technologies. You can have it at the evening time. You can listen my videos. Very simple, easy to understand. There is no complexity while listening these videos. Okay. So now please do remaining students, only 30 students have done. I'm expecting few more students. Please subscribe. First, please subscribe. At least you can listen those videos at the evening time, please. Hello, my dear students. Please do subscribe. And at the evening time, you can listen those videos. Now make sure that, madam, please instruct them, madam. Let them do all students subscription.
Yeah, definitely. Already instructed them, sir. They are doing it.
Yeah, yes, sir.
I
Just
think due to some network problem, somebody's getting that, sir, and somebody is
internet. Yeah, yes, sir.
Yes.
Maybe internet problem, sir.
Actually, they are not provided 5 password, so they are depending on the net.
Yes, sir. Thank you, sir. Yeah, any doubts, my dear students? Please ask me now. Any doubts related to transformation action? Now we are moving to next topic. So still half an hour time is there. Any doubts? Please ask me, madam. Please unmute them. Let them ask any doubts, madam. Few students can they can do subscription. Please ask any doubts. Very simple transformations and actions. And theory part, I think you can study very well. Easy. I think Satish, thanks to Satish sir, has explained very well all the fundamentals. The way you are answering all the questions, very nice. Because I'm testing in industry also, few people are not answering few questions, but you students are answering very well related to my questions. So thanks to Satish sir, sir has given wonderful sessions for you. You you students are so lucky enough having a great professor like Satish sir. And yeah, please ask me any doubts. Otherwise, I'll ask you questions. Can you answer? Shall I ask questions? Okay. Shall I ask questions? If you are not asking, definitely I am going to ask questions now. First question, what is Apache Spark? Can anyone answer? What is meant by Apache Spark? Please. Yeah, please respond because you are very good students. You are responding very well. Spark and PySpark. Spark is a framework and Spark is a processing engine in order to process the big data sets. Open source tool. Spark is a processing engine in order to perform various data sets by using machine learning library. Spark consists of HDFS and MapReduce. Spark supports 4 programming languages: Scala, Java, Python, R. List few actions in Spark. Anyone? Please.
The collect, reduce.
Yes, correct. Very good, very good. So
Format
graphics. Yeah. So what is meant by Spark core? Spark core. Can anyone? What is meant by Spark core? I'm asking this question for a tech consultant of PySpark consultant questions. I'm asking you very simple questions. So Spark core consists of. Yeah. Spark core supports Spark SQL, mlib, Spark streaming, and graphics, Spark R. See here, my screen is visible. Please see right side, Spark is there. Right side, Spark. So Spark core engine. So it supports Spark SQL, Spark streaming, mlib. We are using machine learning algorithms. Graphics, graph computation like Facebook application. In order to solve a Facebook application, we are using graphics. So each user is a node. Graph in Facebook, I'm connecting all MVGR students. How many students are active in Facebook? Tomorrow morning, I would like to find out how many users are in Facebook. So that application I'm going to generate with help of graphics. Okay, now see the differences between Hadoop and Spark. Okay, so Spark Hadoop is a framework which supports various tools like Flume, Scoop, Hive, HBase, mlib, Pig, Zookeeper, Woozy, Cassandra. These are the tools are integrated with Hadoop. Whereas a Spark, see here, the core engine of entire Spark framework provides utilities and architecture of other components. So Spark SQL, it is used for structured data, can run unmodified Hive queries on existing Hadoop deployment. So Spark streaming is nothing but flow of data. It enables analytical and interactive apps for live streaming data. So MLIP, it is a machine learning libraries being built on top of Spark. So you can solve classification, clustering, association, rule mining, various algorithms you can use in MLib. Then GraphX, graph computation engine combines data parallel and graph parallel concepts, especially in Facebook application, Twitter application, and any social network applications. Then Spark R on Spark. So package of R language to enable R users to leverage Spark power from R cell. So R also supports in Spark framework. Okay. Now see the performance between Hadoop and Spark. How it is going to perform performance. Okay. So the performance in the Hadoop, the step one, write once and then performs the step. Then again, so many readings from hard disk. So in Hadoop, write data or read data from hard disk every time. Every time the data set loads, the data is very huge, very large data set. So every time it is loading from the hard disk means it becomes slow. That's why it Hadoop runs on batch processing system, number of tasks, group of tasks performing as a batch processing system. So whereas in Hadoop, see here in the diagram, first time it loads from the hard disk and then every time it loads. That means write once, read many times in memory computation. RAM symbol is there. See here, here RAM symbol, random access memory. That is volatile memory, temporary memory. So memory is two types, permanent memory, temporary memory. Memory is used to store the data. Okay. So ROM is a non-volatile memory. I mean, okay, non-volatile memory, hard disk. So here every time in Spark reads from in-memory computation. Next, see ease of use. Ease of use in Hadoop. So here we are using MapReduce is a programming model where we are writing Java code in Hadoop and compile it, debug, execute, and finally deploying application. So that is front end. In back end, we are using HBase and Hive. Those are the database and data warehousing tools in order to creating unstructured database as a database. I mean, we are creating unstructured data as a database. So Hadoop can be integrated with multiple tools like Scoop, Flume, Pig, Hive. So you may get a doubt, sir, Hadoop also supports Python, R, C++ and Java. Java is ultimate. Hadoop written in Java programming. Whereas in Spark, Spark written in Scala. So Scala supports 4 programming languages: Python, Scala, Java, R. So Spark comes with user-friendly APIs for Scala, Java, Python, R, and Spark SQL. This is the use of ease of use. Next, cost. See here how much cost consumption happening between Hadoop and Spark. If you see in Hadoop, so every time it loads from the hard disk, read-only memory, ROM. So it consumes more data and less computing power through RAM. So Hadoop requires lot of disk space as well as faster disk. Yes. So that's why the cost consumption is more in Hadoop, whereas in Spark, Spark requires large amounts of RAM for executing everything in memory. Yes, in memory. So Spark is 100 times faster than Hadoop because it requires large amounts of RAM for executing everything in memory computation. Okay, that is a difference between Hadoop and Spark with parameter cost. Next, data processing. See the diagrams, all of you. In Hadoop, Hadoop is a framework. It runs with batch processing. That means group of tasks is called as a batch processing for a historical and legacy data sets. It perform very well, not for real-time processing. So data processing means it takes more time in Hadoop because it loads data from the hard disk. Suppose it is works in the client server architecture. So client stored the data, again client stored the data, and number of clients are storing data, and you are performing ETL means extraction, transformation, loading. ETL tools like Informatica, Hive, these are the ETL tools clients. So Hadoop takes data processing, is time is more. Whereas in Spark, it takes a streaming processing. Stream means flow of data between server to server or server to system to system or system to server. So streaming processing, especially for stock market data and traffic data and YouTube streaming data. So it reads one time from the hard disk, and data processing can be done every time with in-memory computations. See here. So the client is requesting and reading many times. The loop forms in the diagram. It based on the streaming processing. Then next is fault tolerance. Keep in mind, fault tolerance is one of the important characteristic of Hadoop and Spark. Fault tolerance is nothing but if any error occurs in a data center or any program or anything, any type of mistake or error or any fault occurs in a system, so it acknowledges to the master node or administrator with a heartbeat which server or which node is not inactive. So fault tolerance is effectively works in both Hadoop and Spark frameworks. So whereas in Spark, RDD is automatically recomputed by using the original transformations because so it replicates itself. So replicate function is available in the Spark, and there is no if replication function also there in Hadoop, but it takes time while processing in Hadoop with the help of disk processing concepts. So fault tolerance in both cases it works effectively, but more in Spark because it is very automatically recomputed by using the original transformations. Next one is security. Security is nothing but it is one of the challenge in Hadoop and Spark. Still R&D is ongoing on both cases, but they have integrated with the high security mechanism in both frameworks. Still there may be a chance if you are connected to the online or any streaming processing application also. Be careful of intruders can enter into our system or domain. They can steal our data. So security is always a challenge or a problem or issue in both frameworks. In Hadoop and Spark, see here. So here login attempts, then from the computer to login attempts from the server, from the hard disk. Then you are entering into the password and loading direct application processing in Hadoop. Then check if it is okay. The process is running okay. Everything, the application is running smoothly. Then you can log in with the security manner. Whereas in Spark, see here, so high security because you can incorporate with B's public key, A's public key, then combine keys, and you can perform A and B shared secret key. Then high security mechanism in both the processing engines. So these are the major parameters for comparing performance, ease of use, cost, data processing, fault tolerance, security. Okay. So then Hadoop use cases, if you see Hadoop use cases, so here, so servers, collection of integrated servers at one place is called data center. The data center is a backbone of big data or cloud environments. So you can store in archival data, that is called repository. What are the free repositories available in the worldwide? Can anyone answer for this question? Archival data. Suppose I want to take data from various websites, streaming data websites, or archival data, or any websites, any data sets available in the worldwide. Can anyone answer for this question? Where I can download free data sets? Please
Kaggle.
answer. Yeah, Kaggle. Very good. Who's that? Please name.
Tani.
Shravani. Okay, give her big round of applause. Kaggle website and UCI website. You know, these are the big repositories in order to download any kind of data set irrespective of type of the file, Excel file, CSV file, SQL file, flat files, and JSON files, audio file, video file, streaming file, any kind of files you can download, X-ray images data set, and movie data set, or NASA data set, weather forecasting data set, retail market data set, supermarket data set, and various kinds of data set we can download from the very good open source repositories called Kaggle, www.kaggle.com, and you can check in the website also, www.uci.com. So these are the two big remaining also there, even Google database and Amazon database. Some few data sets are also available, but commercial few. But free open source repositories, Kaggle and UCI websites. Okay. So you can use reporting tools like Tableau. Tableau is a reporting tool. Data stage, you know, data stage is a reporting tool. Cognos is a reporting tool. So with help of reporting tools, we are generating various graphs. Like in Python, we are using matplotlib. And in R programming, we are using Google ggplot. And various programming languages, various libraries are presented. So application requires batch processing in a Hadoop use cases, like in a healthcare data, or in case of any kind of applications. I have explained this one. And fourth unit where I stopped. This Spark context I have completed. Functions I have completed. Then Spark session I have completed. Then RDD. These transformations I have completed, and actions I have completed. Okay, there are two types of transformations like narrow transformations and wide transformation. So in narrow transformation example, map, flat map, map partition, filter, sample, union, etc. And narrow transformations like map, filter, wide transformations are group by key and various transformations. Then actions we have seen collect, take sample, take first, save as text file, save as sequence file, count by key for each or common actions in Apache Spark. Okay. Then these are the differences of transformations and actions. See here. So we are using transformations and actions. So reduce, collect, count, first, take, save as text file, count by key for each. These are the actions. And map, flat map, filter, group by key, reduce by key, map values, sample, union, distinct, sort by key. These are the transformations. So what is meant by data frame? Data frame is a terminology used in Spark, is a distributed collection of data organized into named columns like attributes, like dimensions. So data set is a collection of rows and columns. So data frame is nothing but it is a distributed collection of data organized into named columns. Columns are playing a vital role in order to perform any data set. Okay, columns are dimensions. So which column is high priority? How do you calculate? So based on the information gain, Gini index, we are calculating information gain and Gini index. By that we can say that this uh, this column like student data set, I can take a target class. Target class is a pass or fail, true or false. So target class is a prime attribute, prime column based on Gini index and information gain. So data frame is nothing but conceptually equivalent to a table. Table in a relational database. I think everybody knows table. Table is a collection of rows and columns, especially in SQL, MySQL, Teradata, DB2. DB2 is a product of IBM company. Keep in mind. MySQL is a product of Microsoft company. It is a open source. Surprising. So data frame in R and Python, we can use that same terminology, but with richer optimization under the, it works only on structured and semi-structured data. It organizes the data in the named column. Data frames allows the Spark to manage schema. You know, schema means relation. Relation means procedure. Procedure means structure. Okay, based on the schema, based on the relation, based on the structure, based on the procedure, we are creating the tables in SQL and MySQL. Collection of tables is called database. To manage the database, we are using various softwares. Okay, and so that is called schema. Data set, it also efficiently process structured and unstructured data. It represents data in the form of JVM objects, Java virtual machine, of row or collection of row objects. That is called JVM Java virtual. It is a platform independent in Hadoop. Every system can execute it to its own. It creates its own bytecode. So bytecode you cannot understand. It is a stream of bits. Okay, machine can understand that bytecode. That's why every system has its own JVM. So So it represents data in the form of JVM objects of row or a collection of row objects. So this is about a data frame. Then RDD to data frames. So this method, how do you can convert? This method can take an RDD, resilient distributed data, and create a data frame from it. So the create data frame is an overloaded method, and we can call the method by passing the RDD alone or with a schema. We can observe the column names are following a default sequence of names based on a default template. This is called RDD to data frame. So catalyst optimizer, Spark optimization techniques are there. Can anyone knows Spark optimization techniques like using accumulators, Hive bucketing performance, predicate pushdown optimization, zero data serialization, deserialization using Apache Arrow, garbage collection tuning using GIGC collection, memory management and tuning and data locality. These are the various Spark optimization techniques are there. This is advanced question. Don't confuse now. So I'm explaining Spark optimization techniques because I'm handling these days. Last 4 months back, I have joined in Deloitte as a subject matter expert. I'm conducting interviews for who are having 10 years experience in Spark and big data tools and PySpark especially. I'm asking the question like, can you list out what are the Spark optimization techniques? They are answering like, yes, sir. I know Spark optimization techniques are using accumulators, Hive bucketing performance, predicate pushdown optimization, zero data serialization or deserialization using Apache Arrow, and garbage collection tuning and using GIGC collection, memory management tuning, data locality. If time is there, I could have explained each one optimization. I think what is the time now, madam? So 7:53. So, sir, 7 more minutes are there. I think theory part you may in future again if sir gives one more session, I am going to take and complete practical session and remaining concepts I am going to explain if time permits. I'll discuss with sir because now time is in my country 7:30 right now. So 7 more minutes are there. Any queries, anything would like to ask me, please, you can freely ask. I can stop here and see these are recently I have conducted this is your college international webinar, and this is I have conducted 1 day workshop on business data analytics using machine learning and deep learning techniques. And this is at Srinidhi Institute of Science and Technology, Hyderabad. I have conducted 1 week online short-term course on AI application with machine learning and deep learning techniques with use case studies. Then this is a Rathinam College at Tamil Nadu. I have conducted data science applications using machine learning and deep learning techniques. And this is at Ghaziabad, one of the institute, model institute. I have conducted data interpretation and statistical analysis with SPSS. And this is at one of the college, JNTU, JNTU Kakinada. I have conducted data science applications using machine learning and deep learning techniques. This is Research India Foundation. I have conducted various research tools, data analytics tools. Then This is at Bansal College, Engineering College. I have conducted data science and applications using ML and DL techniques. This is Mahendra Engineering College, computer aided drug design using machine learning and deep learning techniques. This is cyber security in my country. In my college, I have conducted cyber security applications using Python. And this is Sairam Engineering College at Madras. I have conducted artificial intelligence in healthcare applications. And this is at Vikrant Engineering College, Gwalior Indoor. Data science applications using ML and DL techniques. This is Ravindra Engineering College at Kurnool. I have conducted data science and artificial intelligence. This is SKC LNCT Group of Engineering College at Indore. I have conducted data science applications using ML and DL techniques. Maharshi Markandeya University, I have conducted data science applications using ML and DL techniques. And this is SSN College at Chennai. I have conducted big data analytics using Spark. And this is Maharashtra, one of the engineering college. I have conducted data science applications using ML and DL techniques. And this is a VET Institute. I have conducted online data analytics concept using Spark technology. And this is cyber data analytics topic I have explained. And this is Oman at Saudi Arabia. I have explained the data science applications using ML and DL techniques. This is Reva Engineering College in Bangalore. And this is VET Institute. I have explained the concept data science applications. This is in my country, in my college, I have explained mobile application development using Python programming. This is Maharshi Markandeya Engineering College. The topic is data science application using Python. This is cyber security in my college. This is cyber security in my college. This is Annamacharya Institute of Technology. I have explained data science application using machine learning algorithms. This is Chalapati Engineering College at Vijayawada. So I have explained the data science applications using machine learning and deep learning. And this is Annai Salai College of Engineering. I have explained big data and cloud computing technology. This is Chadalavada Engineering College. I have explained the recent trends in applications of mathematics. Then KL University, I have explained robotics process automation. KL University by using a UiPath. Then this is Krishna University, Machilipatnam. I have explained the data science applications using machine learning and deep learning techniques. This is research conclave on research methodology at 49 countries in Africa. I have conducted research conclave. And this is Vijnana Bharati Institute of Information Technology. I have explained implementation of data science applications using machine learning algorithm. This is Karpaga Vinayaka Engineering College, Tamil Nadu. COVID-19 virus detection using deep learning techniques. This is Reva Institute, Reva University. I have acted as a research panel member on various IT trends. Then this is a data science using R programming in my university. Then Lord's Institute, I have explained IT career and opportunities. And this is a Bhartiyar University. I have explained statistical analysis using SPSS tool. And this is data science symposium I have conducted in my college, in my university. This is at Russia. I have conducted a webinar on COVID-19 strain virus detection using machine learning and deep learning techniques. And then big data on applications using PySpark in my university. Then this is at Russia. I have conducted COVID-19 virus detection. And this is data science applications. This is at Oman, big data analytics using Spark. This is in my university data science applications. This is Maharshi Markandeya Engineering College, Big Data Analytics using Spark. This is Jaya Engineering College. I have explained Big Data Analytics using Spark. This is ABS Engineering College, Ghaziabad. I have explained the essential of emerging technologies on AI, machine learning and big data in research. This is Sangam University at Rajasthan, Big Data Analytics using Spark. This is Indian Institute of Science Education Research Center at Tirupati, ISER. I have explained big data and cloud computing technologies. This is Gautam Institute of Information Technology, ICT based pedagogy in engineering education. This is international seminar at Salem. And this is at Best Local Chapter Award IIT Madras in the year 2019. I got Best Local Chapter Award from IIT Madras. And this is Best ITAP Teacher Award from ITAP Hyderabad in the year 2020. And this is a Bharat Vidya Ratan Award from Global at Delhi 2018. And this is a doctorate degree from Anantapur, JNTU Anantapur. And this is a keynote speaker at SITM Tirupati. And this is one of a jury member at Madanapalli, MITS Madanapalli. And this is one more resource person at Sri Vidyaniketan Engineering College. This is one more resource person at MITS Madanapalli. This is keynote speaker at Geetam. And this is international conference at Singapore. This is international conference at Thailand. This is international conference at Thailand. That's all about from my side. And any doubts from participants, please ask me. Thank you, sir, Satish sir, for giving me this wonderful opportunity, sharing my knowledge with the wonderful students at MVGR.
Thank you very much, sir. Actually, this today's workshop is very informative to all our students.
Yes, sir. Thank you, sir.
Sure, like that. Actually, my name is Relay Professor. I am an assistant professor in CSE department, MVGA.
Yes, sir.
Actually, I'm very much happy to be a part of this workshop. And
Yeah.
these students corrected. I informed all my students and instructed them to attend this workshop seriously. They have all participated and they
Yes.
have learned a lot from this.
Thank you, sir.
Yeah. So
Any
very much.
student
Thank you very
feedback,
much,
sir? Any student feedback?
Actually, the students they are busy with some other works. Actually, now they are trying to leave, sir, because they are having another session
Okay,
in the
sorry,
afternoon.
sir. It's okay. It's okay,
And
sir.
we have taken the feedback, sir. And
Yes, sir.
just give me a moment, sir.
Yeah.
Hello. Just give me feedback. Pogalan. Yes, sir. The students are coming.
Yes,
Students
sir. Yes, sir. So make sure all the students has to
One thing I just want to tell you, sir. I just want
Yes,
to add
sir.
one thing. Already I have
Yes.
attended a workshop on 2 years ago, sir.
Oh, where,
On the
sir?
data analysis in Spark. Yes. Actually, when I was in a Vijnana Engineering College, I have attended the workshop.
Oh,
I think in
thank you,
2018,
sir.
I think so.
Yes, sir. Yes,
So
sir.
at that time, when I attended, I got the PPT, so that I preserved the PPT. Somehow it was very useful to me.
Yes. Okay. Sir.
So
Thank you, sir.
then I have shown this to Satish sir, and then sir immediately identified that he is Ashadi Srinivas sir. He knows me very well. Then
Yes,
sir
yes, sir.
immediately spoke to you.
Yes, sir. Yes, sir. Yes,
Yeah.
sir. Thank you, sir.
Sir, students are there.
Yes, sir. How many students are there, sir, right now?
Actually, the students are leaving, sir. Now I think
Yeah.
10 students are there
Okay, okay.
because they
Okay,
are
sir.
eagerly they have to go for lunch, and again another session is there for them in the
Oh,
afternoon at
sorry,
I
sir.
think at 1:30 p.m.
Oh, okay, okay, sir. Okay,
It's
sir.
a
Thank
very
you, sir.
tight schedule, sir. And from Monday onwards, again they're having mid examination as well.
Okay,
So,
okay, okay.
yeah. Right. Students are there, sir. Please, sir.
Yeah, yeah, yeah. No problem.
Thank you, sir, for this session.
Yeah. What is your name?
My name is Hari Krishna Priya, sir.
Hari Krishna Priya, please read all the concepts, whatever I have presented in this PPT. It is useful for your interview. Okay. Definitely you will get a very good job. You can become as a data analyst or a data scientist if you're strong in this area. Okay. So
Okay,
if
sir.
your sir, Satish sir permit me, we can have more sessions on data science. I am expert in data science with practicals. Okay.
Definitely, sir.
So
We look forward with you in very near future, sir. Because I am
yeah.
also very much interested in data science and its applications.
Yes, sir.
And
Yes.
personally, I myself is looking for a PhD admission in the data science domains.
Oh, definitely,
Eh,
definitely. I am
Yes,
going
sir.
to help you. Don't worry. I am
Definitely.
going to help you.
If everything goes well, I may choose you as a guide.
Yes, sir. Yes, sir. I can be a co-guide. You can choose. No problem. I'll give you my
Yes, sir.
profile
Yes,
to
sir.
you.
Yes.
You
Yes,
can
sir.
use for your.
Yeah, definitely.
Yeah.
I've been looking for an admission, sir. That is the only thing that is left for me.
That also I'll help you. If you are interested, I'm going to help you in WIT and KLU and Maharshi Markandeya University. If you are interested, I have a contacts over there. You can join.
Definitely, sir.
Yeah,
In
yeah.
Andhra Pradesh, sir, is there any contact with
In
any
Andhra
university in
Pradesh,
Andhra Pradesh?
in JNTU Anantapur, but you need to get, I mean, a written test and a gate if something process is.
Okay, okay.
So,
Yes, sir.
but
Yes,
I
sir. There
can,
is a
yeah,
process.
but yeah, yeah. In WIT
But
Vellore,
by
if
any
you are
chance, if I
interested
get it,
directly, in WIT Vellore, I can directly get you for admission in WIT Vellore. I have very big
hello, sir.
contacts. Yeah, WIT Vellore, sir. If you are
Sure, sir.
interested.
Sure, sir.
Yeah.
I'm interested only, sir. Anyhow, I'll go through once I go through the process and I'll go through in detail about all these things. Sir,
Yes,
can you
yes.
please? Okay, I'll take your number from the Satish, sir.
Yes, yeah, yeah, sure, sir.
I'll get back to you
Or
personally.
you can take my number and WhatsApp me. So I'm
Please give me
comfortable
your
in
number, sir.
WhatsApp. Yeah,
Please provide me.
94902
94902
46442.
46442.
Yes,
Yes,
sir.
sir.
Sir,
94902 46442. Yes, sir.
yeah, yeah. You that is only WhatsApp, sir. No local call
Ah,
because I
sure,
yeah
sir.
because I'm in
That is
abroad.
enough, sir.
My number will not work.
Yes, definitely. If this works well, that's enough, sir.
WhatsApp is okay. Sir,
Yeah,
and
sure, sir.
please
Definitely.
inform to students,
Sure.
people make sure them a subscription so that they can listen my videos and they
Definitely,
can
sir.
give
Already
my
instructed all our
feedback.
students.
Yes, sir. Yes, sir. But
Sure, sir. Definitely.
only 50 students they have registered, sir.
Yes, sir. Yes, sir. But anyhow, in the afternoon session, they are having in the laboratory, sir. Once I
Yeah,
go
yeah,
to the lab
please.
and then I'll inform all of them to subscribe and view
Yeah,
those
yeah, yeah.
videos.
Yeah. Give them any feedback, no problem. Write them any
Sure, sir.
views.
Definitely, sir. Definitely.
Yeah.
Definitely, sir.
Okay, sir.
Definitely,
Leela
sir.
Prasad, sir. Thank you for giving
Sir,
me wonderful opportunity. Thanks to
thank
Satish,
you.
sir, especially. Immediately he
Definitely, sir.
asked me, immediately I have agreed, sir.
Yes, sir. Sir,
Irrespective
actually,
of,
I myself and Satish sir were sitting and we are worrying about this one, sir. And
yeah.
immediately I have shown this PDF, then Satish sir identified that it's you, and then immediately he called you.
Yes, sir. Yes, sir. Yes, sir.
Thank you very much, sir.
Sir. Okay, sir. Can I
So
leave, sir?
definitely, yes, sir. One day, definitely, very soon I'll get back to you, sir, regarding the
Yeah, yeah, sure.
PhD admission.
PhD and data science. If you organize data science for faculty, I'll explain and for students also, sir.
No,
So,
definitely, sir. I
yeah.
think even in our college recently, four more new branches were introduced for CSE in the branch of CSE, sir, like data
Oh, very
science,
good.
AI, and
Yeah,
ML.
yeah, yeah.
So
Yeah,
I
yeah.
think definitely we need a lot of workshops for
Yes.
the emerging technologies like these things.
Yes, sir. Definitely I'll help you, sir.
Sure,
Okay,
sir. Sure,
sir.
sir. Thank you,
Thank you,
sir.
sir.
Thank
Yeah.
you very much.